Welcome, and in this video course we are looking at the CyberOps Associate version 1 course. This course is going to cover the skills and knowledge needed for successfully handling the tasks and duties, responsibilities of an associate level security analyst working at a security operations center. The goal of this video series is to help prepare learners for the Cisco 200-201 certification that's focusing on understanding the Cisco Cybersecurity Operation Fundamentals course known as CBROPS. Module 22, Endpoint Protection. We're going to be looking at things like anti-malware, some form of host-based IPS and IDS, as well as application security. So first section is Malware Protection, or commonly referred to anti-malware. This is going to be the nice, lovely umbrella of like antivirus, anti-spam, anti-malware, anti-malicious code, essentially. Endpoints are hosts, servers, access points. Well, access points could be an intermediary device as well. Phones, printers, anything that the end user directly interacts with is typically an endpoint. And the fun part with this is every different type of endpoint can be attacked differently. Each endpoint is also a way to get access to the network. Devices that remotely access the network are susceptible to like injection-based attacks. There are commonly found malware that changes features regularly. So if we're looking at what malware is today, it's sophisticated, it's adaptive, it is modifying itself all to avoid detection and evade our protection-based tools. Early 2000s, we were barely getting any malicious spam. Mid 2015, we've seen little spikes. Anything post 2016, we are talking a ton of malicious content because they've learned that it pays. It learns that our users are not trained. It learned that it's easy, they being attackers. Oftentimes when you go through your training, you see that attacks are coming from inside or on the LAN. And that is because more and more attacks are happening from within our LAN, not coming from outside. Now, that's kind of subjective because in reality the attack is coming from outside, infecting an inside machine, and then they're pivoting from the inside machine to attack the rest of the internal network. So yes, the attack is originating from externally, but they're infecting one or two machines and using those machines to attack the rest of the LAN. It is important that we spend equal time talking about LAN security as we do outside security. It's not just about protecting the perimeter. It's about protecting the entire network in general. After an internal host is infiltrated or attacked, they can be pivoting from that machine to the rest of the network. There are two internal LAN elements. There's the endpoints, that's the devices we use, and infrastructure, that's going to be the interconnecting based devices, the routers, the switches, and other hardware appliances. The question then becomes, can we target the endpoints? We already know that with malware and viruses. Can we target the infrastructure? Can we target the routers, the switches, the access points, the IPSs, the IDSs, the firewalls? And of course we can. There are attacking vectors for just about everything. So how do we target a switch? How do we target a router? That's going to be slightly different than how we target a PC, just like how we target a tablet or a mobile phone. They're all slightly different, because essentially they're all the same in terms of they all have processor, memory, storage, and so they're all computers, whether they be a smart computer or a dumb computer. Host-based malware protection, meaning it's host-based. That means the malware protection is on the host. which is different than network-based malware protection. Host-based are going to be individual machines, typically a computer or a laptop or things like that. That's going to be your anti-malware traditional software, your AV, your anti-malware, things like that. The big takeaway here are there are a few different approaches on how we can do this. Signature, behavior, heuristic. So a signature-based will recognize various characteristics of a known malware file based off of a signature. Could be a hash, could be the way it's coded. It's going to be looking at various characteristics to recognize what a virus would look like. For example, I have a privilege escalation batch file that modifies Windows 10. It's something that I know is legitimate, but because it does certain behavior, it is flagged as a virus. Well, because that is more based off of behavior, it's not signature based. Portions of the code are similar to the signatures of other viruses, so it actually does get flagged in both ways, because some of the signatures are already known viruses, so that portion gets flagged, and then that behavior, and that will, the analysis of the suspicious behavior in that example would get flagged because of the behavior portion. Then we have lastly that heuristic based version, and that will recognize general features shared by various types of malware, and it's not looking at the signature or the behavior, it's looking at a collection of features, and based off of that will determine if something is malicious or not. So a common thing here is false positives. That is where something actually gets flagged as negative and in reality it's not. This is a virus. No, it may have a signature similar to a virus, for example, but it's not a virus. With host-based protection, it normally is an agent-based protection, meaning there has to be a client or an agent on the machine that runs on each of the machines to protect each of the machines. The agent provides the protection. So what's some of the common host-based protections outside of a antivirus or anti-malware? Is the host-based firewall. In Windows, we have a built-in firewall. That's the Windows Defender firewall, sometimes referred to as the Windows Defender and Advanced Security. This is a host-based firewall. It's installed on a Windows client. It allows you to do ACEs and ACLs based off of applications or port numbers or file hashes, things like that. Some firewall software can prevent the hosts from being infected. Some firewalls can also log to and from traffic that is more suspicious. We also have other host-based security suites like traditional antivirus, anti-phishing, web browser safety like safe browsing. We also have host-based intrusion and prevention mechanisms. Most host-based security software normally has a lot of logging features. The nice thing with that is if we log everything, we can analyze the logs and look for possible infections or an indicator of infection. The independent testing laboratory, like AV Tests, does provide high-quality reviews of host-based protection so that you can see which protection is best for your situation. Not all situations are equal. Not all host-based security suites are equal. Not all host-based security suites are going to work in every situation. So you want to look at your situation and find the tools that are appropriate for your situation. Since we talked host-based, we have to talk network-based as well, because there is network-based malware protection that are going to be running on network appliances. We can have next-generation firewalls, we can have network IPSs, we can have network access control, which is always really funny because lots of organizations know about it, but they don't actually set that up. gateway security appliances, as well as endpoint security suites for the endpoint before they're allowed to get on the network. That's going to be a combination of the network access control. The network portion is all about being able to protect the endpoint in a more borderless network, meaning we're not tied to the traditional network design. So you can use a combination of network-based as well as host-based techniques. That is the fun part when we talk security of endpoints. We're not talking that one is better than the other. It's about a layered approach, or defense in depth, DID. So here is some forms of network-based. We have advanced malware protection that will be tied to the network. We have email security appliances, web security appliances, as well as network admission control. The NAC actually looks at a profile of each client trying to connect to the network, and then it will determine if it's allowed on the network or not. If a client doesn't have up-to-date version of the OS or hasn't ran an antivirus scan in a week, or for example, then the network admission control could actually segment that machine until it meets the profile criteria, and then it would be allowed on the network. We have web-based security appliances. That is going to be things like filtering or blacklisting of sites, email security, or more like anti-spam, and then we have the advanced malware protection, and that's going to be the endpoint protection from virus and malware that's attached to the network. Alright, so let's talk host-based intrusion protection, or it will be intrusion protection focusing on host-based tools. Again, we've already looked at things like the firewall, but on each machine, whether it's a Windows, Linux, or Mac, we also have things like the IP tables or the NF tables, and that's going to be the Linux firewall. We also have a TCP wrapper, and this is the rule-based access control and logging system for Linux. There are other variations of this for Windows, but we've already looked at several of the host-based tools for Windows, so now we have to look at the Linux versions. Again, host-based has personal firewalls, software programs that are already built into the host's OS of almost all common operating systems. We have things like a host-based intrusion detection system. That is going to be a IDS that is attached to the host as opposed to the network. HIDs can perform detailed monitoring and reporting. Again, IDSs, the intrusion detection, is more logging and not so much action-based. It logs and it alerts. It'll let you know what's going on. From there, we can actually put agents on all machines, and then we can have a log machine and an alert machine. That way the logs, everything that happens goes to a logging machine or logging program, and then the alerts based off of the security event could go to an appropriate person. IDSs are comprehensive applications, and this can include functionality like anti-malware, antivirus, firewalls, and everything else. Again, intrusion detection systems can run directly on the host. If they are, that's a HID, and they are considered as an agent-based system. That agent could also supply other security suites. You could have an agent that is the antivirus and intrusion detection system. We have anomaly-based or policy-based versions of our HID. The anomaly-based is going to be behavior that's compared to a learned baseline, and if things are abnormal, then it will throw up a red flag. If it's policy-based, this will be behavior described by rules or the violations of such rules, and then that will then result in a red flag. So again, IDSs have two main types, anomaly and policy-based. One looks at a baseline, anomaly. One looks at a set of rules or predefined settings, and that's policy-based. Alright, so what are some common HIDs? We have things like the alien vaults, We have Cisco's AMP, we have open source HIDs, we have like OSEC. So there are different versions of HIDs out there. It's just a matter of what do you have. Then we also have hybrid like Snort. Since specifically they brought up the open source HID, also known as OSEC. OSEC uses a centralized server or manager, and they can receive and analyze alerts from the other devices, and then from there they can push out alerts as appropriate. Alright, now let's talk about application security. Because when we talk in devices, it's not always about the hardware. Alright, so attack surface. This is going to be the total sum of the vulnerabilities for a given system that is accessible to an attacker. So when we talk about an attack surface, it's what from a system can the attacker actually target. The more we expose, the more the attackers can actually target. Things like IoT or other cloud or mobility, BYOD, all of this has increased or expanded the attack surface. So why do we do it? Because our workforce keeps changing and shifting. So our attack surface is growing, and so security must grow to protect the new formed attack surface. Components of an attack surface could be things like the network attack, that's exploiting vulnerabilities in the network, software attack, that's again attacking the software, or we could be attacking the human element of the network as well. We have application whitelist and blacklists. Whitelist would be the allow, blacklist would be the deny, and we actually have the ability to say everything is blacklist and only allow the things that have been approved. That is more of a zero trust model, which is not always the best, but it is a way to secure some networks. Application blacklists, again, dictate what can and cannot be ran. This means that a vulnerable application may not be allowed on the network or allowed on a machine, so it does provide some protection. It does mean more overhead. You can actually, through a Windows local policy, disable specific applications from running. And you have the same thing to do using like the Cisco Talos Security Intelligence Service, and that will be actually be obtaining like blacklists. For a Windows machine, we can have an agent on the machine, and that will let us look at certain things as well, or prevent certain things from running. Now we have to talk about sandboxing. So sandboxing is a technique that allows suspicious files to be executed and analyzed in a safe environment, essentially like a virtual machine. We have things like Kako. I always pronounce that wrong. I apologize. That's a free malware analysis tool. And we have any.run, which is an online tool that offers the ability to upload the file to a repository, and then it is ran, and then it is looked to see what's going on. This is way more advanced than what most people have to go through, but this is for analysis of suspected malware. We do have a video in our lecture looking at the launch and sandbox of malware. Alright, so let's go and let's wrap this up. We talked about threats to the internal LAN. We talked about host-based and network-based applications like firewalls and IDSs. We looked at application whitelists and blacklists. And we looked at a few new terms: antivirus, anti-malware, endpoint, sandboxing, host-based and network-based firewalls, host-based and network-based IDSs, as well as attack surface. And that is all I had for this chapter. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.